Hi folks, I am Yashwant Kanetkar and today we plan to understand a very interesting mechanism used in Java inheritance chain, namely the dynamic dispatch mechanism. Let's now try to understand this with the help of a program. Suppose we have a problem like this to solve, wherein within a window we propose to draw a variety of shapes. Maybe some circles, some rectangles, so on and so forth. Now here if you observe carefully, not only are we interested in drawing the rectangles and circles, additionally we want that the order of drawing of those shapes should be preserved. What do I mean by this? From the figure you can very well see that firstly this red circle must have been drawn, then a blue rectangle, then the pink circle and then the green rectangle. That must have been the order because that is how they have been superimposed. Now when I minimize the window by clicking on this minimize window button, window will disappear. It will go to the taskbar. After some time if I again click on the taskbar, the window should regrow to its original size. Once the size is restored, this order should still be maintained. First red, then blue, then pink and then green. So that order I should be able to maintain within my program. Then only I would be able to restore it. So if I am to ensure this, then I can create a shape class which is generic, and then from this shape class I may inherit a new class called circle, and from the same shape class I can also inherit another class called rectangle. This inheritance relationship once I have constructed within my program, I need to store every new circle or the rectangle that I draw. For them I would naturally create an object in memory. Somewhere I need to gather all these objects, and that somewhere is nothing but an array of shape references. So within that array of shape references I would store the circle objects addresses, similarly rectangle object addresses. And then through a loop I can make calls to the draw function, and appropriately the circle or the rectangle class's draw function should get called. Let's see this code in action. I will first begin by declaring the class shape, within which we will have a simple draw method which maybe draws something or prints something on the screen. Right now we are just trying to provide a dummy draw function without anything within this pair of braces. These are empty right now. But in reality what I would do is I would actually have the code here to carry out the drawing of a shape. But realize that when I say draw a shape, I don't know which type of shape are you going to draw. That is why we should purposefully keep the base class, that is shape class's draw function, as empty. And then within circle class, which I extend from the shape class, I would have a draw method written once again. Means I am overriding the base class draw method. That is why I am saying we can leave this empty. And within this we will print out a message system.out.println circle. In reality I will have a logic here to carry out the drawing of a circle. Then put the closing brace. Then another inheritance chain that we want to construct is the rectangle class, which we extend from the shape class once again. Inside this also we will have a draw method which prints out a message system.out.println rectangle. So from shape I inherited circle, from shape I also inherited rectangle. Then let's try to use these classes. So within main what I would do is create circle objects. Realize that C1, C2, C3 are right now only merely references. We will have to say C1 equal to new circle, C2 equal to new circle and C3 equal to new circle to create the objects and store their addresses in C1, C2, C3. Same thing I will do for rectangles. Create rectangle objects, store their references in R1, R2, R3. And then all these references together I will gather into a shape array in any order that you want, C1, R2, C2, so on and so forth. And once all these references have been gathered into an array affords me to do the iteration on it. So I can now run a loop saying I equal to 0 to 5, because totally there are 6 shapes that we have drawn, C1, C2, C3, R1, R2, R3. So 0 to 5, 6 times. Each time through this loop I would say SI dot draw. When I do this SI dot draw, the appropriate classes draw gets called. What do I mean by appropriate classes draw? Well, when I is 0, that time this will be S0 dot draw. What does S0 contain? S0 contains C1, means it contains the address of a circle object. Hence this draw will bring us where? To the draw of the circle class. When I becomes 1, this becomes S1 dot draw. What does S1 contain? S1 contains rectangle object's address. So S1 dot draw will bring me where? To the draw of the rectangle class. That is why I am saying that appropriately it will take us to either the draw of the circle class or draw of the rectangle class. And this is happening at runtime. That is why it's known as a dynamic dispatch mechanism. Dispatch mechanism means function call. Which function would get called? Well, that would be decided dynamically at runtime based on whatever SI fetches you. If SI gives you circle object's address, draw of the circle class would get called. If SI gives you rectangle object's address, it will then call the draw of the rectangle class. So suitable classes draw would get called. That is what is dynamic dispatch mechanism. Few tips about it are in order. First is that whenever you store the address of the derived class object into a reference to the base class, that process is known as upcasting. And the reference is known as an upcasted reference. So array that we created, it was really an array of upcasted references. In shape reference, we were trying to store addresses of circle objects and addresses of rectangle objects, making them upcasted references. And since there were many of them, we can call it as an array of upcasted references. Then there is a concept known as binding, which decides which function to call. Either binding or dispatch mechanism, that's one and the same thing. In Java, this binding is always done dynamically, that is at runtime, whereas in C++, you can also do it statically, that is at compile time. That is why C++ also offers you early binding apart from late binding. Now question comes as to why Java doesn't let you do early binding. For the simple reason that in Java all objects are always created on the heap. Whereas in C++ you can also create them on the stack. So using the object you can make a call in C++, that's when early binding happens. But using a pointer to an object when you make a call in C++, that's the time when late binding happens. Since in Java objects are always nameless, they are always created on the heap and they are always used through their references. Hence calls to methods will happen through references, and since these are upcasted references, you will land into the suitable classes draw function. Since this happens at runtime, Java offers you only late binding or dynamic dispatch. So early binding and late binding is also known as static binding or dynamic binding, or compile time binding and runtime binding. So this terminology might be different in different languages, but basically the concept is same. Java lets you do only late binding or only runtime binding, or lets you do dynamic dispatch. Early binding cannot be done in Java because in Java you can never create objects on the stack. Goodbye, good luck, and thank you.